All right, welcome everyone back to our next talk, Proactive Programming from PJ Hagerty. So we had PJ already in our awesome keynote earlier this day, but in case you missed it, PJ is a developer advocate, founder of DevRelate.io and member of Open Sourcing Mental Illness. He's also developer, writer, speaker, musician, and community advocate. So he currently holds the position of head of development or head of developer relations at Mattermost. Without further ado, I will just jump right into the talk and enjoy it. Have a nice talk.
Awesome. Thanks, Jonas. Let me share my screen. We'll get right into it because I know that we have a lot to talk about. So yeah, welcome to the talk. This is Proactive Programming. Oh, started on the first slide, but let's go back to the beginning, shall we? So this is a talk called Proactive Programming. As Jonas said, my name is PJ Hagerty. I work at Mattermost. You can find me on Twitter at @asplenic. It's because I don't have a spleen. There's a whole story behind that, but that's a different talk. In case you missed it this morning, Mattermost is a safe, secure, open source communication and collaboration platform for developers, DevOps engineers, and QA engineers. It's on-prem or in the cloud. We make sure your team and projects can run smoothly, safely, and securely. Feel free to check it out. You can actually join the Mattermost community server, community.mattermost.com, and find me, pj.hagerty there, and I can tell you all about it. I forgot to mention this morning, but I also work at Open Sourcing Mental Illness, soon to be renamed Open Sourcing Mental Health. This is an organization that works to talk about mental health specifically in the technology space. We try to get speakers to events like this, meetups, conferences, in-services, talk about mental health and how people in tech are affected specifically. So if you're interested or curious, please feel free to reach out to me or check out osmihelp.org. It's very important that we tackle this issue. It's a big issue in our industry. Again, I'm a developer advocate. That means I get to speak at conferences like this. I build internal tools. I help people with meetups and stuff like that. Also, I'm a musician, have been since I was about 6 years old. A hockey coach. I used to coach hockey. I once let my daughter keynote a conference, and I think that pretty much covers it. I think we saw most of that this morning. So let's get right into what we're here to talk about, which is proactive programming. So to start off with, it seems a little bit odd, but we're going to talk about something that's a little bit different in a different way. Proactive programming sounds like you probably know exactly what it means, and to a degree you do, but we're going to go much more in depth than probably your current understanding of it. So just to let you know, there's going to be quite a few animated GIFs. It's kind of a thing when I was doing this, so prepare yourselves accordingly. Before we begin, I always think it's important to establish some terms that will help facilitate our conversation. These may not be terms that we use in the canonical definition of the word. It might be that we're using them a little bit differently for the talk. And that's why I want to make sure that we're all understanding everything on the same level. So let's define some of the terms we're going to be using and go from there. First off, proactive programming this should be really easy to define, if not so easy to execute. The idea is to eliminate problems before they become problems. It sounds simple, right? No. What we're going to focus on in this talk is tools and techniques to make the process easier. That said, we're not talking about some kind of like weird psychic ability where you're like able to determine what needs to be done before it happens. If anyone could do that, none of us would need jobs. QA wouldn't even be a thing. The idea behind proactive programming is pushing the concept of isolating variables that might be easy to mitigate in order to prevent future issues. We'll take a look at some of the things that we do as we move on, but for now, we know what the term means, and that's a good start. Reactive programming. Now, this is the example that we're more used to seeing. This is what we see with most modern non-compiled programming languages like Ruby, PHP, Python, any form of JavaScript. The data we wish to manipulate or interact with controls the flow of the program. This means we can make changes to the underlying architecture to see changes reflected in the user interface. The positives can be numerous here, and we'll outline those as we move along, but there's also quite a few negatives that we need to be aware of. We'll also check those out. The feedback loop. I'm sure we're all familiar with the idea behind the feedback loop. It's one of the most important concepts in technology in general. The ability to keep moving forward based on the feedback the process itself is informed us of. It's a little bit wordy, but that's how it works. This is the way that we understand what we need to do and is a major part of the proactive concept. We'll look more into the tools on this later, but the point is feedback loop is really a key component to proactive programming. Observability. According to Rudolf Kalman, who coined the phrase, and we're going to use anyone who's going to, here comes the definition voice again. Observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. Now, clearly, this definition was developed from an understanding of engineering complex machines like a car engine or a train, motor. This is where moving parts are internal and their dynamics could only be monitored via extrapolation. Unfortunately, that definition doesn't apply for modern application development and the infrastructure monitoring necessary to keep the world moving with the technology that we're building. Engineering has experienced a cultural shift that requires live observability and data-driven monitoring. Now, we'll take a look at redefining this as we move forward. But first, let's get through some ideas. Let's start with reactive programming, since it's something we all know. As mentioned before, reactive programming is the common model. We build, release, users do something, maybe what we expected, maybe not. And suddenly, we need to iterate, rebuild, and release. Even with the modern QA cycle, the reactive model is most common. The get to MVP as quickly as possible philosophy is mostly at fault here. And we talked a little bit about that this morning, about our willingness to innovate. We live in the land of the VC-backed startup, though. Is it the modern snake oil? Maybe. Is it a great viable business model? Maybe. That's a discussion for another time. What we do know now, though, is that reactive programming is fast and it can get us to our goal quickly. I'll give a great example. For a long time, I was a Ruby on Rails developer. Ruby on Rails is still used in a lot of startups because it gets you 90% of the way in 10% of the time. That's its whole tagline. And it is, that's very helpful, but at the same time, it's very difficult to actually say, how are we building this to move forward? Reactive programming speed is interesting in the fact that it leads to another very Silicon Valley startup concept, pivoting. If we build something, say an interactive game or a Facebook game, but people really enjoy the chat function and not really the game, we pivot. For those of you who don't know, that's how Mattermost was born. We built a video game. It was called, was it Slap Punch? Slap Punch. Slap Punch is still a game that you can play. You can still find it. But what we found was there was a chat component of Slap Punch that people really enjoyed. That eventually became Mattermost. Many companies work to build a specific vision. The question is raised on how that vision is executed, but also on how the end users and community distort this vision through their own lens. Since we're reacting to their input, it's necessary to adjust, change, and sometimes completely abandon parts of the vision so that we can have it laid out in a way that makes sense, as opposed to the way that it was laid out initially. That's how reactive programming works. In reactive development, you solve matters as they arise. This can spark creativity. You can focus on the progress rather than optimizing for millions of users or security threats that aren't there. When you're starting out, when you're building something, there aren't millions of users. There's maybe 4 or 5. But you should, prepare yourself a little bit for the future, right? When issues come in, you're expected to have some sleepless nights. That's just going to happen. This is where our modern concept of DevOps and the site reliability engineer comes in, along with a slew of other support roles and functions. The entire QA team is based on preventing the problems of reactive programming. Common ideas such as being on call or pager duty have proliferated due to the inability of reactive programming to be sufficient for the stability of our applications. The problem with reactive programming is that most of the control over the development is now outside of the software development. Oh, what just happened there? Looks like I stopped sharing. Hold on. There we go. Hopefully, Jonas, can everybody see my...
Yes, I can see it again.
Okay, excellent. Right, okay, so where was I? So the problem with reactive development is that most of the control over the development is now outside the software development and QA team. For a simple bit of code with a few architectural needs, this user-driven approach has a good chance of succeeding. A fairly verbose user with a decent vision of how to really solve their own problems can articulate the interface and data required, leaving the programmers to fill in the blanks. This works so long as the bulk of the programming is primarily business related. It's, however, slow, and it kind of results in a lot of code being disorganized and redundant. We're reacting all the time, so we're doing lots of patching, lots of pointless building. So this makes it seem as if reactive programming might not be quite as fast as we originally discussed. And there's a catch. It's always the first build or MVP, then you're playing catch up with the user for the rest of the time. If your user's needs outstrip your ability to keep the code up to date, you will fall behind. You will lose customers, and eventually you will experience a slow and painful death. I know that seems really dramatic, but bear with me. This is not an unusual story. Very few startups have the resilience to build on their mistakes. Heck, very few old corporations are able to move along without somewhat of a pivot. And again, we mentioned this earlier, but just because you're so large that there's lots of money in the bank doesn't mean that your ability to move forward is easy. And huge companies, your Microsofts, your IBMs, they are able to deal with their mistakes because they do have a lot of money in the bank. Startup generally does not. You have very little runway. They love to say runway. For the most part, if you don't have that money in the bank, you can only afford so many mistakes with reactive programming. Reactive development approaches have been popular, though, for decades, mostly as an alternative to the failures of big, slow-running projects. When the scope of a project bloats heavily, the various forces involved can accidentally send it off on an unreasonable course. Because the timescales were so long, any misdirection, any mistake could take a long time to detect and then cost a lot to correct. The reactive idea was that a much larger number of smaller changes driven directly by the users would ensure that the users get exactly what they specified. In a very real sense, that's what reactive development achieves, but not always at scale. In short, we can't just keep doing this because it's the way we've always done it. Reactive programming works in theory in the same way that the agile workflow works in theory. When the rubber meets the road, things change rapidly. That change will determine whether a development team is organized enough to move with the times or if they just get left behind. So let's talk a little bit about proactive programming, since that is the title of the talk after a while. My apologies for drinking, and very dry in here. Again, I need to reiterate that proactive programming is not an all-seeing, all-knowing mastermind. It's nice if you can get the gig, but it's unlikely any human I've ever met is qualified for it. Being proactive means there's considerable work to be done first to establish a base for handling other issues. The initial code doesn't solve the problem. Rather, it sets up the organization necessary to be able to do that in the future. Now, this doesn't mean you're giving up your flexibility or the iterative nature of reactive programming completely. What it does mean is you'll need to build a toolkit to plug holes and patch leaks before they happen. So just so everyone knows, I'm going to talk a lot about building homes here. I don't know a lot about building homes, but the metaphor works, so bear with me. Think of proactive programming like building a house. You start with a strong foundation. Regardless of what happens as things progress, that house is going to be safe. It's going to stand up because you've built it on something that can't be shaken, theoretically. In the case of reactive programming, our foundation might be flexible, but it's far from sturdy. The idea is built, but it looks more like a pillow fort than a mansion. While it's fun and it looks cool, it's not going to be very helpful when the wind and the rain come in. Being proactive means we're expecting the rain at some point. We know it's going to rain. We might not know when, but we know it's going to happen. So we prepare. We put in nice double-paned windows and dependable roof tiles and the stuff called ice sheeting. I just learned about this. Apparently, ice sheeting, you put it under your roofing tiles so that if there's a rain or a freeze, you're protected no matter what, even if nails go through it. Wild. Yeah, obviously, I'm going through some home repairs, so I'm projecting. My apologies. In proactive development, you solve matters before they become an issue. You generally spend more time on the optimizations. For example, improve security or caching everything so that your site can be used offline. Proactive development makes developments more stable, but you could anticipate the wrong future and end up spending lots of time on something that isn't important. This is where you hear terms like observability and chaos engineering tossed around. We'll talk more about both those things in a bit. But for now, be aware that there'll need to be a schema shift if you're moving from reactive to proactive situation. Just like when you abandon waterfall for agile and then went all DevOps. I'm gonna catch probably some questions about this in the end, but yes, it is a slow shift moving from reactive to proactive. But be aware that if you don't make the first step, you can never move from any of those things. When it comes to proactive engineering, the focus is on being safe and secure, as safe and secure as you possibly can, um, before things head out into the world. This means having a super tight feedback loop. Feedback loops range from end user feedback to QA teams to CI/CD to automated tools that tell you whether or not something's working the way you expect it to. Unit tests are included in the feedback loop. Everything from unit tests to a full QA run are included in the feedback loop before you release. And we'll take a look at a few of those tools in a few minutes. But keep in mind that as we look at the tool, the most important tool is the people that you have executing the vision. None of this works if the human factor is made to feel irrelevant. It's very important that you keep in mind that humans will catch things that no machine or automated process will. Also, humans have to have a really good understanding of how exactly this is supposed to work, what we're expecting from it, so they can see when the unexpected comes out. The key drawback to proactive development is it will take more time in initial stages. Things can be fast and flexible, or they can be sturdy and secure. Pick one and decide what works best for your organization. Chances are security is at the top of the list, so proactive will be a bigger benefit. So let's talk a little bit about the feedback loop. As we discussed before, we know the feedback loop is a key to what we do. It informs us and allows us to make adjustments and learn from the behaviors of our users, past and present. This means we can work toward proactive development based on our reactive past. So if you want to get started in proactive programming and you're already doing reactive programming, you kind of can finish step one. But feedback requires tools that humans can use. Humans, as in general, we really enjoy using tools. But let's not shine our modern star too brightly either. Humans have been building tools to make their tasks easier since long before now. Like since long before humans. That, however, is a talk for another time. Some of the modern tools people use include monitoring, continuous integration, continuous delivery. QA tools continue to grow as well. Everything seems to grow so that we can move toward this proactive model. Another piece of that concept is chaos engineering. And here's the quick primer in case you didn't see it this morning. Chaos engineering is the concept of testing systems live, production systems, at times to see if they're resilient enough to sustain through utter chaos. The concept was developed at Netflix. They're usually the best example, and it's spread into many organizations since, going so far as companies building chaos engineering as a service around the idea. And that's when you see companies like Gremlin that help out. What chaos engineering really provides is a way to get a glimpse of what's happening when the worst occurs. Say half your production instances in AWS suddenly fail, or there's a DDoS attack and your site's hit. How well does your system perform? Does your application remain available to most users, or is it complete crash? Are you done? Knowing how things will get handled, not only by the application, but by your team of engineers, is key to understanding where the flaws and strengths in your application might be. It's key that you test these things out before they go into major parts of production. You need to know what's going to happen. The next key featuring to like the proactive programming feedback loop is observability. This is the direct feedback from your application infrastructure and all the other systems that allow you to see how everything is functioning from sandbox to testing to production. This is a time when a lot of folks would write code, no tests, no QA, and deploy directly to production. So anybody ever been in a situation where people just write code, no tests, no QA, and deploy directly to prod? That time's in the past. We're better than that. I really hope we're better than that. Please let us be better than that. Please. Luckily, here we have great tools like Elasticstack, Humio, Splunk that can see into the system from end to end in more or less real time. Don't get caught up on the idea of real time. But it's not only the tool. Things like Travis CI and GoCD can let you know where there's hiccups long before they hit production. They'll catch code issues before they actually get to the QA team. All of this helps complete that feedback loop. But let's look a little more deeply into observability, because I think that's where this crowd is really interested. Take a sip here. So monitoring methods and tools are now more sophisticated and more widely adopted to handle increasingly distributed complex systems. When I began my career, the concepts of observability were so minute that it was kind of like literally you would just send commands into a command line on a server and hope for the best and hope you were getting back the right thing, but you had to ask for the right thing. Now it's easier to observe code and test and extrapolate that behavior. It's also true that all bets are off once code hits the real world. For the modern tech world, we've seen the need to redefine observability, as we mentioned earlier. For us, observability is the ability for teams to view information and investigate further how a given system is performing in real time, or as close to real time as possible, allowing for adjustments and fixes in order to create better systems and identify threats in any complex computing environment. Real time is super critical when it comes to application development monitoring. Most tools focus on digesting information and kicking back out after a certain period of time. That might not be ideal for many teams, especially those who are deploying multiple times a week or even per day. Whether a sandbox environment or production cluster, systems need to be monitored in concise intervals, near instantaneously. We need to find tools that give us the feedback as quickly as possible. We can't see a full picture without making all aspects of what we're trying to observe readily available. Modern infrastructures generate tons of unstructured data, but often we only really sample small parts due to hardware constraints or high licensing fees or things like that. Slow query speeds and long latencies between ingest to search makes that data not available fast enough for us to have quick analysis. A lot of times our users are still catching issues before we do. And complicated, complex solutions that aren't easy to use, query, deploy, or manage mean limited usage and limited pleasure in actually using them. This ultimately results in outdated observability for just parts of our system. Removing these obstacles empowers users and teams to quickly and easily query, analyze, and visualize all their data instantly. Data-driven observability is the key. It means you can leverage all of your log data and use real-time streaming capabilities for querying and dashboards, things like, to build up and understand what's going on, VNOCs. And that powers live system visibility for all the engineers, not just the ops or the ops-minded DevOps folks. QA can look in and see how long a QA run takes. It can see maybe what the problem or the tooling is that's making mistakes. Everyone has the opportunity to see under the hood. Making systems better is the goal of observability. The more we know, the more we're able to improve and adjust, the more proactive we can be. It's commonly said that software development is never finished. I thoroughly believe that. With this in mind, being able to observe and monitor what's happening out in the world allows teams to build better, smarter, and get closer to the goals we keep pushing forward. From a tooling perspective, this requires handling large data volumes efficiently and executing ingest and search with sub-second latency in a simple solution. But observability is more about tools. And I realize there's a section of this that I did not intend to include. A little bit about AWS. So AWS has lots of tooling like the personal health dashboard, Amazon Redshift, the trusted advisor, and some external integrations. Those are all important if you're using AWS, but we don't need to go over those now. The choice here is up to you and your team. Every organization is different, and no single talk at a conference or meetup is going to change your philosophy of the workflow for your company. There are things that you need to consider as we imagine, create, and distribute software applications into the future. Observability is probably the largest tool in the feedback loop system, and it creates a proactive environment. It's just one step. Combine that with chaos engineering, which resides on what I like to call the observability tool belt, trademark PJ, you're welcome. And there's a way to mitigate and eliminate lots of issues before they even become insurmountable obstacles. Again, tools are great, but they need to be usable and valuable to the humans who are interacting with them. Remember not to get too caught up in tooling. Find a simple thing that allows you to see into your systems and become proactive. Build tests that make sense so that you can see problems before they begin to happen. That puts a lot on you. That's not untrue. Live system observability is about this data-driven, iterative process for teams to improve the overall health and resiliency of their systems. Mitigating the issue of live system observability is at the top of the heap for every modern company or organization. Whoever's developing an application, anyone out there, whether it's for web or mobile, for fintech, or what I like to call fun tech, which is things that aren't things that you really need. Successful tools need to give developers, DevOps practitioners, QA specialists, testers, security operations, systems administrators, site reliability engineers, and everyone else insight into how their systems are functioning in real time. And they need to be built to scale linearly and efficiently store data so users are not wasting their compute resources. You need to put together a stack to be proactive. Their tools are important, but how you use the tools is even more important. And with that, thank you very much. I'm happy to take any questions.
Awesome. Thank you so much. So we have already some questions in the chat, I think.
Awesome.
The first one's really interesting. So it's basically which systems would benefit from the approach develop, deploy to production. So rather than acceptance test, develop, review, approve.
Yeah. So Peter, it's a very old method, and the idea was like a lot of times this is a pre-cloud methodology. So it was like, oh, develop a patch, develop a bug fix, deploy directly to prod. The idea was, oh, we're getting it fixed quicker, so that should help our users more quickly. That philosophy is that's wrong-headed thinking. What you often end up getting is a bigger mistake that needs a bigger fix, and it's just a big, huge cycle. It just snowballs downhill, and you just keep doing it. So it makes more sense to take your time, acceptance, test, develop, review, approve, QA, deploy to prod. That just makes sense. There's not really a place in the modern development world where you just develop and deploy to prod. Doesn't mean people don't do it, but it's not a good practice, and there really is no place for it.
All right. Yeah, so maybe I have a follow-up question for myself. So I see this quite a lot in the startup world. So if they want to validate ideas, they just build like a small, without testing, a small system, and then they like put it away after that. If they see it works, it doesn't work, and then build it from scratch again. What do you think about that?
Yeah, exactly. And that's the key is like you want to make sure that you don't want to tear down your application every time just to see what a problem is. You want to make sure that you can do things iteratively and not retrofit, but build as needed.
I see. All right. Next one. Proactive programming seems to contradict YAGNI principle. How can you be proactive and avoid overthinking and over-engineering stuff, wasting time on solving problems that won't happen?
So that is one of the drawbacks of proactive programming, but I think that one of the key things is experience. I think that there's certain things that you're not going to need to think about. I'll give you an example. At Mattermost, we built our main platform is the messaging platform, the chat platform. We don't need to think about the problem of, well, how do we deal with video? Until someone asks for video, there's no need for us to build that in. That's how you kind of avoid the overthinking, over engineering. Focus on the very basic thing that you need to do. How do you do that safely? How do you do that securely? How do you do that efficiently? Efficiency is definitely a part of proactive programming. We want to make sure that we're building things in a timely manner. It's difficult because not every team can avoid someone who is over engineering things. I worked on a team that we had a very basic application. All we had to do was build surveys. Excuse me. This is a long time ago. The surveys were based for, when you finished a class at university to review that class. He so overthought the user model that users had, I think, 40 different attributes. And he thought he was being proactive, but what he was actually doing, it seemed at the time, was building things that didn't need to be built. Then we realized that some of those attributes would be because the student would eventually graduate and become an instructor or a facilitator. So it turned out that he wasn't actually overthinking or over engineering the problem. He was being proactive. We didn't have to build that. So sometimes we have to get over the idea of over engineering and realize that if we're taking into account the future of the application, sometimes getting things done now means we don't have to worry about getting them done later.
Yeah. All right. So any more questions from the chat? We have some time left, I guess.
Yeah, I'm happy to take more questions, or I know it's getting later in the day on day 2. So, I mean, feel free to reach out to me on Twitter, or feel free to jump on the community server in Mattermost and just ping me at pj.haggerty.
Yeah, sure. All right, so I guess there's no more questions coming in. So thank you all for joining the session, and thank you, PJ. It was awesome having you here, like for the keynote again, and also for this talk. Really looking forward. Maybe next year, I don't know it. Be happy to have you.
Yeah,
I
maybe
guess
in person. Maybe in person.
maybe
That
in
would be
person.
great.
Yeah, would be nice actually. So let's see how this will be. All right, then I guess if there are no more questions coming in, which I don't think so right now, we can end the session and have a short break until the next one.
Awesome. Thank you so much.
All right. All right.
All right.